Hello, everyone. I'm pretty happy to present on the Inference Service that we are deploying at the ALCF. This is going to be heavily focused on large language models. This has been the focus so far, but just keep in mind that as we move forward in time, we have plans to broaden the scope and serve AI and inference a bit more broadly. Okay, I just want to acknowledge also Aditya, who has been the co-developer of this project. So I'm going to present on the behalf of the two of us. And also, there's a big team that is supporting and helping. So I just want to acknowledge them upfront. There's a lot of nice people within the Globus ecosystem that helped us making our model better, more reliable, and help us streamline a few things. There's also Argonne, the cybersecurity team, the GPT project, the Cell IT team as well that all help and is currently trying to support all this project. So although I'll be speaking today, many people are behind and should get some credit. Okay, so ALCF is deploying a bunch of inference and AI clusters, and we have some NVIDIA cluster coming, some Sambanova clusters coming. For our current deployment, we have been using Sophia, which is a 24-node cluster at ALCF. We also use Polaris for the early phase of the deployment. And our grand goal is to be able to integrate with all of these clusters and provide the scientific community massive inference power that they can easily use without having to know how to integrate with these systems or even having an account on these systems. So that's the grand goal. For now, only Argonne affiliated user can use it, but we have discussion ongoing to broaden this and allow more people from the outside Argonne community to use it as well. So what we want to do is to provide really easy to use interface that totally hides the complexity behind the scene. We have a web UI chat interface. The address is here if you want to test it out, but you might not be allowed if you're not from Argonne, but this will be better in the future. So you just go in, you authenticate with Globus, and then you can select among the models that we have live running, and you can just ask your questions. You're gonna just enter a live chat like you would do with a ChatGPT. It has a very nice formatting. It formats tables, equation, codes as well. So this is probably the easiest point of entry that you would want to use if you just want to interface quickly with some of the large language models. We also have an API that you can access directly. So this is for the more savvy user who would like to multi-thread their application, send a bunch of requests. You will also have a batch mode enabled so that you can send many requests at once. This is going to give you a more raw answer with more information like the response time, some token statistics, things like that. And so these are our two options that we have. And for any of these cases, the user should not have to worry about how we actually reroute the inference request, what's all the complexity behind. So that's what we want to do, is to increase to have more computing power behind the scene and allows our scientific user to benefit from them. Okay, from the development perspective, this is a simple overview of how that works. We have the user up top that authenticate with Globus. Then they send our request to our API or our web portal, which will redirect to our API. So we just do some validation there. We verify who the person is, if they are allowed to use the system, which model they are requesting, etc. So when everything is good, we offload all this to the Globus compute service. And currently, as I mentioned before, we use Sophia. So we have a bunch of endpoints that are going to load the specific large language models. They all communicate with our scheduler, run the inference on the compute node. And ultimately, we also going to have more cluster, as I mentioned at the beginning, and our API will be the central engine where it reroutes to many different clusters. We're probably going to use also Globus compute for some of them, but there are some chance that some of them will be reachable directly through an API. So how do we configure this whole thing? So we have, for Sophia, we have a couple of admin, basically me and Aditya, so we cannot be both on vacation for now. We SSH on the login node. Then we have special pseudo rules that allows us to become a service account. That's something we have at ALCF that represent a service. And it's from there that we configure all of our endpoints. And when we configure them, and an endpoint acquires a resource, so it's a two-stage operation. So there's the initialization step, also known as the worker init step. And during that time, this is where the customization is going to happen. We're going to load the targeted large language model in memory on the compute node. And we're using VLLM as a framework right now to serve most of our models. So as part of the initialization, we're going to spin up a VLLM server that will be reachable through an API, but all within the compute node. So that means that when we have a compute task coming through the endpoint that's going to run on the compute node, it will contact the VLLM server running on that node. And that's how we provide the inference computation to the user. Now we have many different models that are persistently served. So it's not you're not going to send a request and wait forever in the queue. So we do have some special reservation on Sophia, such that there are models that are just running all the time. The wall time is like infinity basically. So we have a couple of models that basically have no overhead. There's no cold start, and we also have a bunch of models that are on demand that you can request. But this is just going to submit a job and compete through the queues. In terms of model, we have 30 right now, and the list is continuously growing. And especially once we have our dedicated AI clusters and inference cluster, we will definitely be able to host more models. We're going to be able to have backups for models. So if one cluster is under maintenance, we can reroute to other clusters, etc. So we do have a bunch of different families. And if you need to have a models that is not available, we're always happy to try to see if we can spin that up for you. So don't hesitate to contact us. And this is a little overview of the current usage. We have 70 users for now. We have processed over 8 million requests, which generated about 10 billion tokens. And this is a service that we expand to grow. We expand. We hope that there will be more usage. We are able to have quite a lot of requests asynchronously. Our API is based on a Django Ninja async application. The Globus compute executor can handle quite a lot, so we should be good to go if someone wants to blast it. And this is just a simple histogram showing the number of users who use a specific model. And we're pretty happy to see that a lot of models are actually used by several people. And we think that this is a good advantage to go through our service, that you have a wide range of model and we can always accommodate more model if need be.
One more minute.
And one more minute, perfect. All right, so in conclusion, this is a service that we are starting to deploy. Very happy to interface with whoever wants to use it and help us make a better service. So we have the web interface that's available, and we also have documentation at the ALCF to explain how to use the API. And if there are any issues, you can also like now send a ticket to ALCF instead of sending an email to me and a detail. So now it's a bit more formal. So pretty happy about that. And yeah, that's pretty much it for me. So.